It's very good morning to everyone. So, if you remember in the last session, we started with the lexical convention of the Verilog program, right? Why do we need to follow this lexical convention? I mean, what are the lexical convention of the Verilog is? Lexical convention. What is the lexical convention we talked about this? So, default it is going to escape by ignoring the white spaces, right? So, we talked about this. And what is the next comments? How to do single line comments and the multiple line comments. Then we talked about what? Operators, right? So we talked about operators, the unary operator, ternary operator, and binary operator. Then we talked about number specifications, right? So we're talking about this one, number specifications. So this is a quick recap that we studied in the last session during the topic, right? So basically, number specifications you can do in Verilog two ways, right? What is one way to represent this? Size representation, size, and second one is unsized representation. Unsized representation. So can you tell me what is syntax to the size representation is? Size, right? Right? Size. Tick. Don't forget about when you're writing the base format. The base format should start with the word tick. Tick. Then what we need to write? Base format, then follow data number. So this is the syntax, right? Size number. Can you tell me some examples of the size numbers? Tell me the example number. To take a B00 means what it indicates. It is a size of 2 bits. Binary format. The binary number is 00. So always this size should be 1. Decimal number. It should be a decimal number, right? When you're writing any size number, the size should be always a decimal number. Whether I can write a negative number here, -2, -3, it should be 1. It should be unsigned decimal number. You understand? Now let us continue with today's session. So we were talking about the number specification, right? This is the number specifications. There are two ways of number specification. One is size and unsized. Size number, this is the format, and this is the number representation. Right? So we did some few examples on the size numbers. Now let us continue with another number specification. Verilog is number unsized specification. What do you mean by this unsized means? What does unsized means? Let me place here. There is no size representation. There is no size representation. Number that are specified without a size is not a base format. Without the size specification or decimal number like the to means. So with this respect to this is nothing. But if you are not writing the base, the number by default should be what number it is. What number it is. So usually how you are writing a decimal number. In any application tools, when you are writing a decimal number, you are writing without base. Right? So without base, the number should be always by default it should be decimal number. That is what here. Right? The number that are specified without a base format specification are a decimal number by default. What do you mean by unsized means? There is no size we are going to represent. Now look at this first example. What is this? So is there any base format is there? So by default, this number should be 1. This should be the decimal number system. Now coming to this second example, what is this? It is hexadecimal. What the size is? The size is nothing but this example of what? Unsigned specification. By default, so here unsigned means we don't know what is the size of the bits. Right? TKH C3. So what is the result of this? Nothing but this should be 32 bits. Let me clarify this how it will be showing 32 bits. Okay, size format and unsized format. So let us take one example to this. So let me take module TP. Okay. First let me declare the variables. So I'm declaring the variable using integer. Integer by default size should be how much? 32. It is system dependent. Okay, it will vary system to system or compiler to compiler. Default it will take how many bits? 32 bits. So I'm putting the integer in. Okay, I'm going to write integer in. Mention begin. So now I'm going to initialize the event. Let us take a is equal. What is this first number is? What is 2, 3, 4, 5, 6? So this is 2, 3, 4, 5, 6. This is without a base format. Okay, without a base format. Now let me print this. To print what I can use? I can use the dollar symbol display. So A is equal to. So what number? Let me print in the decimal first. The format specifies is percentage D. What argument I need to pass? A. Okay. Now by default, what is the number? It is nothing but if you write a number specification like this, by default this number will be taken as one decimal. Decimal. Let me run this. You can see it's the same number I'm going to print it. Okay. So if I want to remove this spaces, what I want to do? Percentage 0. Any white spaces are there, it is going to. Now A value is nothing but same. By default now it is taking what number it is? Decimal number. Okay. Now let me print this in the binary. Print this in the binary. What is the binary equivalent of this is? Now to convert this into the binary. Now this will take how many bits? Since I have declared this as an integer, the default size of this integer will be what? 32 bits. How to understand? So the meaning of this first definition is number that are specified without a base format specification, they are what number? Decimal number by default. So I'm taking 2, 3, 4, 5, 6 is a decimal number. This is a what? 32 bit decimal number by default. How to understand? Now let us take this one, unsigned number. Another unsigned number example is the see the number that are written without a size specification have a default number of bits that is depending upon what? Simulator and the mission specific. It must be at least how much? What is the size of this number? 32. It is depending upon what simulator we are using. And also depending upon what operating system, mission specification dependency. Now I'm not writing what in this second example, we are not writing what size of this number. Now what is size of this number? What is the number is? Think H indicates what? Hexadecimal number. C in binary is nothing but what? 1100. 3 is nothing but what? 0011. Now I'm going to give this number. I'll declare this as an integer. Now I'm going to give what is the number is? Think H C3. Think H C3. Now if I print this in the binary, how many bits it will take? By default, since I'm declaring here as an integer, right? Integer will take 32 bits. Now this will be printing 32 bits. Now what is the result? Can you tell me from LSB to the MSB? 1 1 0 0 0 0 1 1. Rest are all the bits are what? Zeros. Right? Now this is the output. 1 1 means this is nothing but 3 up here. 0 0 1 means nothing but 1. See, and all this rest, remaining the rest of this 32 bit will be what? Zeros. You understand? I'm not representing any size. Suppose if I'm representing size of 2, what number is? Now it is size number specification, right? Now it is going to store how many bits it is going to take? Only 2 bits. Now what is my result age? 1 1. All remaining bits are what? Zeros, right? So what number I'm using? What type of number specification I'm using? Size number. So this will be storing as 1 1. All remaining bits are zeros. You can see here. Actually, my bit size is nothing but it will take say 3 will take 4 bits and 3 will take 4 bits. Now here bits are not the same format according to the hexadecimal. It is not constrained. I'm giving size is 2. That is why I'm giving a warning message. You understand? Now it will be storing 1 1. All remaining bits are zeros. Now do you understand the difference between size number and unsigned number? Okay. Now suppose if I'm giving, is it correct way to write the number? C3. Now let me give, okay, don't give the tick also. Is it correct? Usually decimal numbers, what are the decimal numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, next after that 1, 0, 1, 1, 1, 2, so on. By default, your simulator will understand the decimal numbers. If you give this number basically hexadecimal number. Right? So when you are giving the hexadecimal number, you should give the what? What you should include? You should include the base. Right? How to include the base with the size format and unsized format is nothing but take the h. You understand? Now, how many bits we are going to take? 32 bits. Right? So here we take the 32 bits. Since I'm declaring this integer is 32 bits. Right? Now, can you tell me what is the output of this one? Tick O, 2 1. Tick O, 2 1. If I'm printing this in binary, how it is going to be? How many bits it will take? How many binary bits will take each digit in octal? 3. So 1 is nothing but if I'm talking about LSB, so the MSB 1 0 0. 2 is nothing but 0 1 0, and all remaining bits are zeros. Right? Now same number, if I'm going to print this in the decimal, what is the decimal equivalent of this number? C3. The hexadecimal unsigned format. C3 decimal notation is 1. How to convert hexadecimal to a decimal? You should go to weighted power, right? Weighted power. So 3 into 16 power 0 plus 12 into 16 power 1. So this is the equivalent in decimal. This is the number decimal 199. You know how to convert this, right? So how to convert the decimal hexadecimal to the decimal? Weighted power, right? So this number you can write converting this into decimal means 12 into, correct? 12 into 16 power what? 16 power 1. This is 16 power 1 plus. So 3 into 16 power 0 is nothing but 1. 1. So what is it 12 into 16? 192 plus 3. 195. You can understand? Suppose if I am going to print this in the octal, what is the octal equivalent of this number is? How to convert the hexadecimal to the octal? So first you convert this into what? Binary, right? And then group it how many bits? 3 bits. So what is output? So if I want to print this in the octal, this is my number, right? This is my number. If I group it, this 3 bits. This is 3. Again, 0, 3. 3, 3, 3, correct? 3, 0, 3. Result is 3, 0, 3. Now let me print in the octal. So octal equivalent of this hexadecimal number is, it is printing 3, 0, 3. Now you understand this? Now coming to the next story, next example is octal. Octal, unsized format. What is this number is? Tick. Correct? This is a tick. 0, 2, 1. 2, 1. So let me print this in the binary. What is the binary equivalent of this? What is the binary equivalent of this octal number? So this is O. Octal. Tick O, 21. So what is the binary equivalent of this number? 1, 0, 0, 0, 1, 0. Remaining all the rest of the bits will be what? Zeros. This is, it will take the 32 bits, correct? 1, 0, 0, correct? This is nothing but 1. 0, 1, 0 is nothing but 2. And remaining bits are zeros. If I print this in the hexadecimal, what is the hexadecimal equivalent of this number, octal number is? How to convert octal to hexadecimal? First you convert this into binary, then group it how many bits? 4 bits. Correct? So what is the 4 bit means? 1 1. So octal equivalent, hexadecimal equivalent of this octal number is 1 1. Do you understand? So if I print this in a decimal, what is the decimal equivalent of this number is? 2 into 8 plus 1 means it is 17. Oh, this is 17. Do you understand? So how to represent the size and number and unsized specification. So if you are not representing the size, by default, that will be taking the, what is the size you are indicating in the data type. So integer data type whose size is 32. Suppose you are declaring this as a reg. What will happen? Suppose I am going to declare this as a reg. Reg data type. Let me declare this is 7 down to 0. Vector I am going to write here. So what this means then? So reg means only scalar, one bit. Reg is 7 down to 0 means what? It is a vector. So it will take a vector width of how much? 8. Now if I print this in the binary, this octal number, so what is the output of this is? How many bits it is going to take? 8 bits. So earlier I am taking what? Integer. By default integer size will be how many? 33. Now it is taking a size of what? 8 bits. How it is storing the data? How it is assigning to this register A? 1, 0, 0, 0, 1, 0, 0, 0. Total 8 bits. Correct? Now it is printing 1, 1, 0, 0. Correct? 3 bits. Again 0, 1, 0, 3 bits. And last two bits are 0, 0. Since I have declared this register as a reg vector with the width 8. Did you understand this? Okay. Number and specification for size number and unsized numbers. Okay. Now let us go with, along with this ones and zeros, thus Verilog will also supporting, along with these decimal numbers, octal numbers, hexadecimal numbers, and binary numbers. Verilog will support two more values. Those values we call it as a unknown or a Z value. So X is nothing but unknown. Okay. Don't care. Where Z is nothing but impedance. Means it is telling that it is open circuit. Impedance or a floating state. The floating state in Verilog will be denoted by Z. So Verilog has two symbols for unknown and what? Impedance values. The values are very important for modeling the real circuit. You will understand how these values are important in your modeling the hardware. Okay, Verilog. So the unknown value is denoted by X, and an impedance value is denoted by what? Z. Now coming to, there are three examples here. Can you tell me what is this example? First example we do. Whether it is size number or unsized number. Size is what? 12. What format it is? Hexadecimal format. 13x. 13x. How it is going to store? You tell me from LSB to the MSB side. X, how many x's from the LSI? 4 x's. Then 3. 1, 1, 0, 0, 8 bits. Then so the size is nothing but 12 bits here. The size is 12 bit. So it is storing as x from LSB to the MSB, x. Since it is hexadecimal, if I am printing in this binary, that should be denoted as x, and 3 is nothing but 1, 1, 0, 0, and then 1 is nothing but 1, 0, 0. You can understand. Now let us work with this example. So let me declare this register as, let us declare 8 bit register. 8 bit register. Now what is the number it is? It is 12 tick. 12 tick hexadecimal of what? 13x. 13x. Now I am going to print this in the binary. The format specified I am using a binary. So what is the value of A then? How it is going to store in this register A? The value of A is 4x, correct? It is x, correct? Then 3 is nothing but what? 1, 1, 0, 0. And remaining are what? 1, 0, 0. 1, 0, 0. Now if I am making this is 1 tick H3, 1, 3. Yes. Only 1x under LSB. All remaining are what? Zeros. You can understand? I don't understand about this one. Okay. Now coming to the next example. What is this next example? 6 size, 6 tick HX. This is a what? 6 bit hexan number. So how it is going to show? 4x, 2 zeros. Correct? 4x and 2 zeros. Again, in this case, suppose if I am going to remove the size here. If I am going to remove the size, in the same example, how it is going to assigning the value to the A. Now my register size is the 16. How it is going to assign? 16 bit register it is, correct. So if I print this in the binary, x, 1, 0, 0, 0, and then, sorry, 1, 1, 0, 0, 1, all remaining bits are zeros, correct. So this is going to print like this. Since I am not giving the size here, so now this is depending upon what is the size of this. How do you understand? If I am going to give the size as 14, what is the width of this A? This is raised to A, 15. Now it is a 15. Right, the same, but in the last series of bits will be not there, since it is 15 bits. Now it is going to store like this. So total how many bits? 4, 8, again 4, 12 plus 3 is nothing but 15 bits. So what is another second example we have is, it is 6 tick, correct? Hexadecimal, yes. So what is how it is going to assign the value to this? Is it a 6x? This is my hexadecimal number. This is a 4x. All remaining are zeros. So 1, 2, 3. Okay, 4, 5, 6, 6. Okay. So since I am giving this is x, whose size is 6, 15. Suppose if I am going to give 1x, see, then how it is going to store? 4x, then 1, 0, 0. Did you get the difference between this and this? Now it will take how many bits? 6 x's. Suppose if I am giving 8 x's, 8 x's, x values and remaining are 1, zeros. So if I am going to give 1 x, so if I represent this in the binary, so each digit, hexadecimal digit in binary representing 4 bits. 4x, 1 means 1, 0, 0, 0. Rest of the bits will be 1, zeros. Rest of the bits will be the zeros. Did you understand this example? Now coming to the next example. What is this 32 tick BZ? This is a 32 bit impedance number. Z means what? Impedance number. This is 32 tick. You make 32 tick. What is the value of this is nothing but Z. Now how it is going to store? So but my register is 15 size. But the size I am giving 32. Then what is the predicted output of this is? All Z means how many bits sets are? 15 bits. Why 15 bits? Because we declare the register as 15 bits. Now this will print in all 15 inside. Now if I'm going to give this as 31. Now it is taking what? 32 bit value. Z value. 32 in Z. Now let us make like this. X Z. X Z. 4 Z values is remaining all are X values. So 4 Z values remaining all are what? X values. This rule you should remember. If I'm going to give 0 here, 4 Z, 4X, remaining are zeros. Remaining are zeros. What happened if I'm going to give like this? 4X, 4X, 4Z, sorry, 4Z, 4X, 4 ones. Remaining ones are it is zeros. Remaining ones are zeros. It should be zeros, correct? All remaining are what? Zeros. So 1 in, see, X in Z in hexadecimal is Z, Z, Z. In binary is Z, 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 Z. X is X, 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 X. 1 is, this is the 1, 0, 0, 1 in binary. All remaining bits are what? All remaining bits are what? These are zeros. Did you understand? If I'm going to give like this, 1, 1, X, Z. 4Z, 4X, 1 triple 0, 1 3. 1 triple 0, 1 triple 0, remaining are zeros. When you are doing like this, what happens here? It is not filling, the rest of the bits is not filling zeros. This rule you should understand. Now by default, it is filling what? Rest of the bits will be X's. If it is zeros, zeros filling. If it is X, X filling. If it is Z, ZX, 4X, remaining all are what? Z. Only when you are writing 1 ZX, so 1 will be in binary 0, 0, 1, rest of the bits will be filled into what? Zeros. So when you are using 0, X, or Z, the rest of the bits will be filled with what? Zeros, if it is in 0. Correct? Here if it is a 0, rest of the bits will fill with what? Zeros. If it is a X, Z, Z values. If it is X, X values. If it is 1, 1 in binary is assigned and all the rest of the bits will be what? Zeros. You to understand this concept. Now this is printing like 4X and remaining all are what? Z. Are you understand this? So this is regarding about the other two values which is supported in the Verilog is unknown value and the inference value. Now you know how to work with the unknown value and the inference value. So these are the two ways you can represent the number, specifying the number, size number and unsize number. Now let us go with how to representing the negative number. How you can represent the negative number. Before that, you can see here any XRZ set 4 bits for the number is in hexadecimal bits, right? If you are using XRZ in hexadecimal number, how many binary bits it is going to represent X and Z are 4 bits, right? On XRZ set 4 bits for the number in the hexadecimal bits. 3 bits for what number? Octal number. And 1 bit for what? Binary number. You can see the example already we worked with. If the most significant bit of the number is 0 or X or Z, the number is automatically extended to fill the what? Most significant bits, irrespective of what? Respectively with what? 0, X or Z. So this is our example we worked. If my most significant bit is 0, what happening here? If it is 0, X or Z, this 0 will be extended. Correct? This 0 will be extended. If it is Z, Z will be extended. If it is X, X will be extended. But if it is 1, the most significant bit is 1. 1, it is filled and the remaining rest of the bits are filled with what? Zeros. Remaining rest of the bits will be filled with zeros. Did you understand here? This is what the definition is. The most significant bit of the number is 0, X or Z. The number is automatically extended to fill the most significant bits respectively with what? 0, X or Z, not with respect to the 1. So this makes it easy to assign the X or Z value to the whole vector. What is the vector we have declared? The most significant bit is 1. What happens? Then it is also a 0 inside. Did you understand this example? Now let us see that how to represent the negative number. How to represent the negative number? Until now we know that how to work with the decimal, binary, and hexadecimal and octal number. So how to represent the negative number? Negative number representation. So negative number will be represented in the form of 2's complement. 2's complemented number. So they can specify by putting the minus sign before the what? Size for the constant number. The size constants are always what? It should be positive. It should be the positive. It is illegal to have a minus sign between what? Base format. The correct way to representing the what? Negative number is start with what? Minus and then size. Size should be always what? Positive. This minus sign indicates what? This minus sign indicates that this is the negative number. And the size of this is nothing but always should be the positive. And tick. What is D3 indicates here? Decimal 3. You can understand. If I am not writing here minus sign, what happens here? This number is the positive number. Correct? It is a positive number. How to represent the negative number is minus 6 tick D3. So the 8-bit negative number stored in the 2's complement of 1, 3. So this is 3. How it is stored in the system is nothing but in the form of 1. Sign in 2's complementary form. What is the 2's complement of 3 is? What is 2's complement of 3 is? The 3 in binary, how you can write 3 in binary? 3 in binary means 0, 0, 1, 1. Correct? If I take the 1's complement of this, what is the 1's complement is? 1, 1, 0, 0. And if I do plus 1 to the LS of this is equal to what? 1, 1, 0, 1. And what is sign extension to this is nothing? 1. So this sign will be extended based upon what is the size you have specified. You understand? Now let us work with this example. I have declared the register is 31 down to 0 of 8. Now I am going to assign the number. How to assign the negative number is minus. This is denoted by what? 6 tick D. Then how is storing? Suppose I am going to print this in the binary. How this will be storing? How many bits it is going to take? 6 bits. Size I am representing 6. And this is minus indicates 1. It is a negative number. How 3 will be stored? In 2's complement form. What is 2's complement form of this is nothing. This is 1. 1, 0, 1, 1. How many bits are there? 5 bits are there. But my register size is what? 30. So to make it to understand, let me make this into the 8 bits. 8 bits. And how many bits are there here? 1, 0, 1, 1. What is this last bit will be? It is sign extension, indicating that this is the negative number. The size of, what is the size I am giving is 6. So that this will be what? This becomes 1. Total how many bits are there? 6 bits are there. If the sign bit is 1, this will be extending what is the size of this register here? Right? Now what is the A value? What is the A value? Can you tell me? From LSB to the LSB? 1, 0. All remaining bits are what? 1, 1, 1, 1. Right? Now this is how the negative number will be stored. The negative number will be stored in system is nothing but in what form? 2's complement. Sign in 2's complement form. The 2's complement of 3 is nothing but 13 in binary equivalent. Correct? 1, 1, 0, 1 is nothing but 13. And this last bit will be what? The sign bit. The sign bit will be extended with what? What is the register I am declaring here? Correct? If I am making this into 31, what happens? This sign bit extension will be extended to what? Up to the MSB bits. Correct? So this is the one. Did you understand? So let me print this in decimal number. What is decimal number of this is nothing but? What is the decimal equivalent of this? That number 111111 up to 1101. The equivalent of that number is nothing but this is the one. So if I want to print this in the hexadecimal number, this is hexadecimal unit. Correct? 1101 is nothing but D. All remaining bits are what? 11111 was. Means what? FF factor. Did you understand this? How the negative number will be stored in the system? So it is stored in the simulator in the sign into complemented form. Did you understand? Now can you tell me what is the result of this? My register is 31 down to 0. Okay. So I am using negative number representation here. What is syntax for the negative number representation? Minus. Is it number or size? Size. Correct. Then tick. Then what base format? Followed by the number. I can also represent like this also. What is this? Is nothing but. I will remove the size here. This is unsized number. So let me write here. Okay, let us work the previous example only 3. How it is going to store? I am writing minus tick D3 means what? Unsized number. So how it is going to store? Same like what this is 32 bit, right? So whatever the bit size is, it is same like this. So previous one. All these are what? 1, 0. Okay, let me print this in binary. Now this is printing like 1, 0, 1, 1 up to 1, 1, 1, 1, 1. Correct. The same number if I am going to write like this 2. You can see here 2 tick minus 2 tick D3. Now how it will be stored? It will store what? Only 0, 1. What about remaining rest of the bits? Is it 1? Or zeros? 0, 1. Correct. Remaining bits are what? Ones. If I am going to use one ticker D3. All are ones. All are ones. Did you understand size number and unsized number? Now can you tell me what is the result of this? If I am going to make, let me make a 5 ticker minus 5 ticker D5. What is 5 into 2's complement form is? The 5 into 2's complement form is 0, 1, 0, 1. Correct. If you take 1's complement, 1, 0, 1, 0. If I add plus 1 to the LSB, this becomes 1. It should be 1, 0, 1, 1. And then sign bit extension is nothing but what? 1, 1. Since I am giving how many bits here? 5 bits. This is a 5 bit, size is 5 bit. But my register size is what? 32. So that sign bit will be extended to up to MSB bits. Now this is printing as what? 1, 0, 1, 1, 1, 1, 0, 1, 1. And then remaining bits are what? 1, 1. The sign extension has been applied. Did you understand? Very clear? What about this one if I'm going to make like this 2? What is 2's complement of 0? 2's complement of 2, 2's complement of 4, 2's complement of 8, 2's complement of 16. What is 2's complement of 2? 2's complement of 2 is nothing but itself. It's like a 2 only. 2's complement of 4 is what? 4 only with a sign bit extension. Right? If I write a 2, right? 2 in binary 1, 0, 0, 1, 0. If I take that 2's complement, 1's complement of this one, 1, 1, 0, 1, plus 1. If I add plus 1, what is the result is? 1, 1, 1, 0. Correct? And then sign bit extension is what? 1. So I'm getting 2 is nothing but 1, 0. And 2's complement of this is nothing but 1, 1, 0. And the sign extension. Correct? You can understand this. So the result of this is nothing but 1. Did you understand this example? Okay. Then what is this? This is a legal way to representing the negative number. Then this is a correct way to representing the negative number. Here you can see. What is this? 4 ticker. D means 1. Base format. Then minus 2. This is nothing but what? Illegal specification of the negative number. So negative number with the size representation. Negative number with what? Unsize representation. How negative number is stored in the system? Sin it to its complement part. It is stored in a sin it to its complement part. Did you understand this number representation? For the positive number and the negative number. Now let us go with the next is. So in Verilog, underscore characters and question marks will be accepted. It means an underscore character is allowed anywhere in the number except for the first character. Means, let us take an example to this. Let me make this into binary. Okay. Let us make 7 ticker B or 8 ticker B. Let me make this 8 ticker B. I'm making my register size also. The size of this A is nothing but making 8 bits. Now I'm going to write the binary number. What is meaning of this underscore means? I can write 1, 1, 1, 1 underscore 0, 0, 0, 0. So your Verilog will understand this one, this underscore. So by readability, for the easy readability, Verilog will allow us to assign the one underscore. Now this number will be reading as 1, 1, 1, 1, 1, 0, 0, 0, 0. If I run this, I'll be getting the A values what? 4 ones and 4 zeros. 4 ones and 4 zeros. That means that this understanding what? This underscore. Are you clear? If I'm going to queue here like this, underscore 1, 1, 1, and then underscore 0, 0, 0, 0, whether this will be understanding? Is it understanding? It will not understand. See, the underscore character is allowed anywhere in a number except one, first character. So now in this case, what I did here, very first character is 1, underscore I'm using. Now suppose if I'm going to write like this, 1 underscore. Now this is understanding. Now this will be understanding as 4 ones and 4 zeros. So this will be understanding as 4 ones and 4 zeros. So if you are representing underscore in the very first character, it will not accept it. So why it is accepting the underscore means, suppose you have a very big number, 32-bit number, or a 16-bit number. So you can't easily understand, right? Suppose I'm writing a 16-bit number or 32-bit number, zeros like this. Is it I can easily understand? No, right? So that Verilog have a flexibility to allow the what? Underscores. If I'm writing like this, you will be easily understanding. You can understand? So this this thing you should understand. So underscore and question marks allowed in the where in Verilog. So underscore characters are allowed only to improve the readability of the number and ignored by the Verilog. So it will ignore. If you're representing a number with underscore, it will understand and to bring readability. During simulation, this underscore will be what? Ignored. So any question mark in the Verilog is alternative for the Z in the context of the number. Means Verilog will be having, if I'm talking about binary number, 0, 1, X and Z. X is nothing but unknown and Z is nothing but hyper state or a floating state. So this question mark in Verilog is for what? It is alternative for what? Z value. Let us take an example to this. If I'm going to write like this, let me make this in case. 1 question mark, 1 question mark, question mark. How it is going to store here? What is the result of this? If I'm writing 8, it will be 1 question mark, question mark. Is it a 8 question mark? Or 8 is X? What is alternative for Z is nothing but question mark? If I'm writing the question mark here, so this will be taking this question mark is get Z, and this question mark is 1, Z, and this is nothing but 1. And remaining bits are what? 0. Since I'm representing this 1, 0. If I'm representing this as X now, X are decimal. What is this question mark indicates? Now, earlier I was putting by making this into hexadecimal number. This question mark indicates in binary how many bits are required. Question mark is an alternative for the z line. Okay. Now this my register size is 8 now. 8. Now I'm giving one question mark, and the size of this number I'm giving is 8. Okay. Now what is the alternative to the question mark is z. Now what is the value of 8 now? You think 8 is x or 4 is x? 8 is x. How it is 8 z? Because each question mark is alternative for the z value. So this is nothing but this one. You understand that? So alternative to this is nothing but what I'm getting. Question mark. So now if I run this, since my register size is 8, so I'll be getting 8 z. Are you understanding? Are you clear this one? The alternative for the z is nothing but question mark. Verilog will understand the one question mark. If I'm going to use like the only question object, why object? Because my MSB bit is 1. Z. The default here, that z will be extending into 1. MSB bits. So this is also same. Correct? How do you understand this? If I'm writing one question mark, if I'm writing one question mark now, 4x, 1 followed by is. Because 1 in binary is equivalent is 1. 0, 0, 0. 1. 4x from the LSB, correct? And again this is 1. 1, 0, 0, 0. If I'm writing here x, 4x, 4x, 4z and 4x. If I'm writing 0 here, 0 question mark. 4z, 4 zeros. You can understand? So what is the meaning of the underscore and the question mark in the Verilog? The underscore will allows in the Verilog for the readability. And if I'm writing question mark, the question mark will be the alternative for 1, z value. You can understand this? So any question mark, the Verilog HDL alternative for the z in the context of the number. The question mark is used to enhance the readability in the cases. So we'll be talking about in loops. Okay. And then we'll talk about case statement. When we're talking about behavioral model, we'll see what is case X statement and case X statements. Where the impedance value is a don't care condition. So we'll be using impedance value will be considered as a don't care conditions. So if you remember the parity encoder, what is the encoder is? Encoder is using the data compression, right? So 1 0 0. If I'm talking about 4 class 2 encoder, 1 0 0 0 will be encoded as 1 1 1. If I'm talking about parity encoder, assigning the parity to the higher order bits, assigning the parity to the lower order bits. If I'm getting 1 don't care, that will be encoded as 1 1 1. You can understand? If you remember, let me pick the division of that encoder. So if I'm talking about 4 class 2 encoder, 4 class 2, let us make a higher order parity encoder. Higher order parities encoder. What is the 4 class 2 parity encoder is? What is 4 class 2 encoder is? Here is a 1, this is LSB bit, correct? 4 inputs and 2 outputs. My LSB bits are don't case. So this will be encoded as 1 1 1. Correct? If it is next is 0 1 xx, this will be encoded as 1 1 0. You can understand? If it is 0 0 1 x, this will be encoded as 1 0 1. Right? If it is, let me write the next line, 0 0 0 1, this will be encoded as 1 0 0. So if I'm giving the number like this, suppose I'm giving the question mark like this, the question mark indicates 1. This is alternative for the z line. I understand. So we'll be using the case statements are used to build the parity number. Okay. So that is the use of the question mark in the Verilog. Question mark is alternative for the z value. Okay. Now you can see these two examples. What is this first example is? First example what indicates? Underscore. So use the underline the characters for the readability. And what is this example is nothing but 1 0 question mark. This is equal to 1. 14 to be 0 1 z. I understand this. So regarding the underscore character and the question mark. So with this you are understanding how to represent the size number, unsize number, negative number. Then what is the role of the underscore and what is the role of the question mark. You understand? Now let us go with the strings. So what is a string? What do you mean by string? String is a sequence of characters. So that will be enclosed by what? Double quotes. That will be enclosed by the double quotes. So how we can write a string? Suppose I want to print a string. How to print a string? Using double quotes, right? So I want to print a string. So let me remove this one. Let me remove this. So let me write the string here inside the double quotes. String is a sequence of characters. String is a sequence of characters. Let us write welcome to VLSN. This is string. This string is enclosed with what? Double quotes. Now what is output I'm going to give? It is going to print output like what? Welcome to VLSN. Welcome to VLSN. So what is a string? String is a sequence of characters that is enclosed by the double quotes. The restrictions on the string is that it must be contained in a single line. Okay. So that is without a character. So it cannot be multiple lines. Strings are treated as a sequence of 1 byte. Each character will be treated as 1 byte. What is 1 byte is equivalent to how many bits? 8 bits. 1 byte is equivalent to the 8 bits. ASCII value. So what is ASCII is nothing but American standard code for information interchange. So here, so what is the string? Correct. Each character will take treated as how many bytes? 1 byte. 1 byte is equivalent to the 8 bits. What are ASCII numbers? So what are the alphabet special character numbers we are using in the keyboard? All these will be encoded in what? ASCII value. Correct. What is ASCII value for the capital letter A? Capital letter A. ASCII table, you can see the ASCII table. Sorry. This is ASCII table for the capital letters. And this is not having equal plan B. Let us take next one. You can see capital A. What is equivalent to ASCII number is 69. This is ASCII number. Right. So small a is nothing but small a is comes in the range of here 97. So when you are using a string, each string is a sequence of characters. So each character will take 1 byte of ASCII. So 1 byte is nothing but 8 bits. You can understand? Okay. So this is regarding about the string. I'm not going much detail about the string. We'll see later. Just to have a basic idea about what is the string, how we can represent the string. Strings are usually enclosed with what? Double quotes. And what about the second example? This is a string. How it is going to print output? It is this forward slash is taking as an operator or it is a string. The string. Why it is taking as a string here? Because it is included between the double quotes. You understand? So if I print like this, suppose I'm going to write here A forward slash B. Now here forward slash is not an operator. It is a string because I am included with one double quotes. Now this will be printing output as a one. A forward slash B. Now it is printing, you can see A forward slash B. You understand this one? Now let us go with very important lexical convention of the Verilog is nothing but keywords and the identifiers. So keywords are the special identifiers in Verilog, which is reserved to define the language constructs. Language constructs. Now coming back to this small program here, you can tell me what are the keywords? I mean, language constructs here. Module is a keyword, initial is a keyword, begin is a keyword, end is a keyword, and end module is a keyword. All is a keyword. Now here, what are the identifiers? Which one is identified here? TB is the identifier. So which one is a system task here? Dollar symbol is key. So in Verilog, the keywords are the special identifiers reserved to define the what? Language constructs. These are the keywords which are reserved to specify the language constructs. Keywords are usually in one cases, lower cases in Verilog. So identifiers are the names given to the object or a variable. Identifiers are the names given to the object so that they can be referred in the one in the design. So what are the rules to write an identifier? What is the rules to write the identifiers? So identifiers are made up of alphanumeric characters and the underscores. So under dollar symbol. And they are what? Case sensitive. Means if I'm writing the identifier should not start with one. Like this. Sorry. Identifier should not start with one. Underscore. Let me write underscore. Is this any good identifier? Identifier should not start with one. And underscore will be allowed. Sorry. Underscore will be allowed. And it should not allow one. Like a special character. Number it will not allow. It will not. Your identifier should not start with one number. But it should allow one. Underscores. Now if I'm writing like this is a T underscore B. This is fine. Correct? Because underscore will be allowed when you are writing the identifier. Now this is allowed. This is allowed. Now if I'm writing like a T1 underscore B, is it a good identifier? Yes, this is allowed. Right. If I'm going to write a 1 T1 underscore B, so identifier should not start with 1 numbers, but it should start with the underscore or it should start with the 1 alphabets. Right. So in this case, it is starting my identifier start with 1 alphabets. Right. Whether I can use any special symbol like this T1 star B, is the correct way to write the identifier? Is it yes? What are the rules to write the identifier? Special characters are not allowed in the one identifiers. Only one special character which is allowed. And one special character is nothing but one underscore. You understand? So when you are writing the any identifier, you should remember these rules. One rule, first rule is that what? All the identifiers should be start with underscore or alphanumeric. Correct? And it should not start with one numeric or a special character. Only one special character is allowed to write the identifier is nothing but one underscore. Why do we need identifiers? Why do we need identifier? Identifier is used to represent the objects in the program. So let us take integer. This is an integer, is a keyword. Okay, I'm going to write a value. This is nothing but this is an object. This object can be denoted as what? As a value. Correct? So value is a what now? It is a variable. You understand? So what is the use of this identifier is identifiers are made of identifiers are the names given to the what? Objects. Here I'm given to the object called as what? I'm declaring the variable. The variable name is what? Value. You understand? So when you're writing this value, what are the rules you should remember? It should start with the alphanumeric. It should not start with a special character. Correct? Alright, number. So these are the rules to writing the identifier. So identifiers are made up of alphanumeric characters and then underscore and one more is dollar symbolism. Now coming to this example, this is one of my system task function. Correct? This system task function will be start with one dollar symbol. So this is a legal identifier. Correct? The system task function will be start with one dollar symbol. So what are the characters, special characters allowed to write identifiers? When you're writing any objects or names, underscore will be allowed. Correct? When you system task function, this is some keywords for the system task function. Dollar symbol we call system task function. You understand? So let us remember what we identify. This should not start with any special numerical. So it has started number, right? Or sign. See the number sign is past which is from this function. So the communication is here. So this stuff will be start result to result. The option here is result to result. Now, what is system? What is very difficult? Now can you kindly check? Am I audible now? Hello?
Yes, sir. Now what is order?
Yes, sir. Yes, sir. Yeah. We will start with the session. So this is register keyword and value is the identifier. And then input is the keyword, clock is the identifier. Now in this example, you can tell me what are the keywords and what are the identifiers. Module name is identifier. Is a legal identifier or illegal identifier. You can say 1T, 1B and 1B. Is a legal identifier. Suppose if I'm going to write lines. I'm wanting special symbol. Is it a legal identifier? No. If I'm writing like this, legal identifier. If I'm going to write like this, legal identifier. It will allow what? Underscore. You understand? Now here value is 1. Again, I can write a value or I can write like this name underscore value. Is it a legal identifier? Suppose I'm going to write like this. Name hash value. Is it a legal identifier? No. So when you are using any identifier in your Verilog programming, you should understand the rules to write the identifiers. You understand? So with this, you will understand that what are the keywords and what are the identifiers. What is the set of rules to writing the identifiers in the Verilog program? Right. Now let us go with escape identifiers. The escape identifiers are denoted by the backslash character. So escape identifier begin with the backslash character and end with the space or tab space or the new space. How you can use escape identifier is backward slash D is one tab space. Backward slash N is nothing but one. Use it. Backward slash R means tab is written. There are a few more escape characters are there. This escape character or escape identifier always begin with one backslash. Now let us come into this one. So if I'm writing here backward slash 3 backward slash okay, this is one of the escape identifier. So how it is going to be the output is this escape character is what denoted by one backward slash. Now it is giving the two spaces and printing one forward slash and D. So there is a line number 2 is wrong. Why it is wrong? Syntax error because I'm using hash. So to write identifier this is not allowed. Right? Now let us make this. Now it is giving the two tab spaces here and then forward slash B. So this escape identifier begin with the backward slash character and when end with the what? White space or tab or a new line. All characters between the backslash and the white space are processed. Literally, any printable ASCII character can be included with one escape identifier. What is escape identifier is nothing but backslash. Now you can see the backslash or a white space is not considered as a part of the identifier. Now if I'm going to write backward slash A plus B minus C, it's not a part of the identifier. This is also what? Not a part of the identifier. This is a part of the identifier if I'm writing a backward slash D backward slash N. That is a part of the escape identifier. Escape identifier will be indicated by what? Backslash. Are you understanding? So this is regarding about the escape identifier. Some of the escape identifiers are like backward slash and so on. This will Verilog suppose those data types already we deal with that 0, 1, X and Z. So this we call it as a value set of the Verilog. So Verilog supports 4 values and 8 is 10 to model the any functionality of the real hardware. So to modeling to the any real hardware, it will be supporting the 1 impedance and then it is supporting how many strengths? 8 strength. I will show you what are the strengths. Okay, 8 strength it will be supporting. 0 in the condition in the hardware circuit is nothing but 1. Logic 0 or a false condition. 1 is nothing but logic 1 or true condition. X is nothing but unknown value and Z is nothing but a impedance or we call it as a floating state. Floating state, open state. Open state. You understand? So these are the data set values to be supported in the Verilog. 0, 1, X and the Z. And the strength, the 8 strength of the Verilog is nothing but this is the one. The strength level is starting from supply, strong, full, large, weak, medium, small and high impedance. So this is a type. So supply, strong, full, large, weak are the data type. And then medium and the small is nothing but slower type. And then impedance is nothing but high impedance type. So whose strength is starting from? If I'm using the high impedance, the weakest strength. Weakest strength to the what? Strongest. So you don't understand. So in addition to the logic values like 0, 1, X or Z, the strength levels are often used to resolve some conflicts between the drivers of the different strength in the digital circuits. This single strength will be used. So value levels 0 and 1 can have a strength level is taken into here. Okay. Now let us take one example to this, the strength level. In the, for example, in two signals of the strength 1 and the weak 0. Let me take the two signals. This is one signal. This is another signal. This is the strong one. One signal is 1. Another signal is 1. Weak is 0. So if it is strong 1, this is strong 1. This is strong 1. This is weak 0. So if I'm connecting this, means I'm following these two. Means making oxygen of these two twice. And what result I'm going to get for this? One is strong 1. Another one is what? Weak 0. So which one will be having the strongest? Strong 1 or weak 0? Strong 1, right? If you look at this table, weak will be 1. Less degree. And strong will be 1. More degree. So therefore, if strong 1 or weak 0, if two signals of the strength strong 1 and the weak 0 contained are collided or accidental, the result will be resolved as 1. Strong 1. How it is strong 1? Because strong will be having 1. Higher degree of strength. So weak. You can understand? So these are some of the strengths, 8 strengths we are using to model in the real hardware. Okay, this is one example I'm writing here. There are two signals which are collide each other. What is output I'm going to get is nothing but based upon this track. The right strength of the strong is strong 1 and weak 0 is a weak. So in between this it is going to select output as 1. Strong 1. Correct? This is all. In addition to the logic, if two signals are unequal strength, if it is connecting 1 and 1, right? Suppose this is 1 and this is 1, you know what is this, right? 1. Right? If two signals of unequal strength are often driven on a wire, the strongest signal will be 1 to use. This is one example. Strong 1 and weak 0 contained, the result will be resolved as 1. Strong 1. If two signals of equal strengths are driven on a wire, the result will be unknown. If the two signals will be M1. Same, equal strength. If the two signals of the equal strength are driven on a wire, the result will be always, it should be unknown. It should be X. You understand? You can see another example here. The two signals on the strength, strong 1 and strong 0 conflicts. The Y1 is a strong 1, Y2 is nothing but strong 0, both are what? It is getting accident. The result will be what? Unknown. In this case also unknown. You should remember the iterations. So these are the strength levels. High impedance, weakest strength, small, medium is a more strength compared to your high impedance. Then weak, larger, full, strong, and the supply will be having a strongest strength level. Okay? If the two Ys will have the same strength, what the result will be? Unknown. The strong and weak 0, strong 1. Strong 1 and strong 1. Correct. Unknown. Both are same, it should be. You can understand here? Unknown. The strength levels are particularly, why the use of the strength levels are, it is going to making operatively modeling the real hardness. So that we will be using this strength. Take strength we will be using to modeling the real hardness. You can understand this? What are the values set are given? 4 values set. 1, 0, 8 sunset, and 8 price minutes. Okay. Now let us take a 10 minutes break. Okay. After the break, we will start the session. We can take a break for 10 minutes. Like side number, unsize number, negative number, and then we talk about what underscore, what is the use of underscore, what is the question mark, and we talk about what strings, and then how to make a string. Then set values. What are the 4 set values and 0, 1, x and z, and then string, drive string. Okay. Now let us start with what is a nets in the Verilog, and what is a net and regs register in the Verilog. So net represent a connection between the hardware units. What do you mean by net in Verilog is nothing but it is a connection between the 2 hardware units. Let us take an example. Let us take an example. This is my 2-input NAND gate. Let us take 2-input NAND gate A and B, and this is another gate, OR gate. This is my output one. What is a net represent here? What is a net? So net is used to connection between the 2 hardware. So I can call this is nothing but a net, or let us take Y. So this we call it a net. So what is the use of a Verilog is nothing but it is used to representing the connection of the hardware. Connection of the hardware we call it as a net. So net represents the connection between the hardware elements. Nets have a value. What value it will be having? Whether it is capable of storing the value here. This we call it as a continuously driven. This we call it as what? Continuous driven ones. Net are continuously driven value. So when A changes and B changes, Y also changes. W1, Y1 is also changes. So this is not capable of storing what? Data. It is not going to retain the data. So that we call it continuous driven data type. So net is a what data type? It is nothing but it is a continuous given data type. It is not going to store what data. Are you understand? So net is a connection between the two hardware elements. We call it as a net, and this net is nothing but what? What is this? This is continuous driven. So this discrete driven is nothing but one. Register type of the discrete driven data. Why? Because that is the discrete driven RC preserves the data. We call it as what? Register data. Register is discrete driven, and the Y is or net is a continuous driven data. You can understand. First, understand the definition, then you can easily understand. Net have a value continuously driven, and then by the outputs of the devices that they are connecting into it. Net is will continuously assume the value computed at the output of the gate G1, which is what? Which is B and C. So this will be continuously assuming that value is computed. Correct. When A changes, B changes. In this case, B changes, C changes. It continuously assuming means computed the value of Y. Correct. So let us see. Here in this case, A is I'm giving A is 0 and B is 0. This Y value is continuously computed. If A is equal to 1 and B is equal to 1, this Y value is continuously computed. Whether I'm going to store any value here? No, right? This type of hardware connection, this connection between the two hardware, this line we call it as what? Net data type. So net or Y data type also net or Y. Interchangeably we call net and Y. Okay. So this we call this continuously driven data type. Are you understand? What is a net? What is a net? It is a connection between the what? Hardware elements. So why we call this a continuous driven? Net is having a continuous driven on them. Because the A changes and B changes, so your Y will be continuously it is changing, computing the value. But it is not what? Storing. So since it is not storing, I can call it is nothing but continuously driven. It is continuously computing the Y value where input changes. A changes or B changes, that we call it as a net data. So nets are declared primarily with the keyword called it as what? Y. So in this case, suppose I'm asking you to write a gate level model to this. Gate level representation. How you can write the gate level representation of this? So first you are going to write module, correct? Module name you are giving. You know how to write the module name with the identifier, right? So I take A1, correct? Then you are declaring the what? Inputs and outputs. What are the input and output declarations? Port list, A, correct? B, C, right? Correct? Now what you are going to declare? Port declaration. Here, what are the ports are? What are the input ports are? A, B, C. What are the output ports are? Output is what? Y, correct? And then this net data type is declared by keyword is what? Y. And now I am going to declare this as a Y data type, Y, W. So where Y is a what? It is continuously given data. Are you understand? Now, how to write the gate level model to this? Gate level model to this diagram. You are going to instantiating the NAND, right? NAND, correct? The NAND of, let me give N1 is the name of the instance of outputs, right? What is the output is? W1, A, correct? Then in this, and what you are going? R. So like this is N2. What is the output is? Y, W1, C. W1, C. You understand? Now with this, you are understanding what is a net. Nets are declared using what keyword? Y key. Correct? So now here Y is nothing but 1. W1 in this circuit. Are you understand? So this nets are declared primarily with the keyword called as a Y. Nets are 1 to 2 value by default, unless they are declared explicitly as a vector. If I am writing up, this is Y of W1 is nothing but what? By default, it is a default of what? 1 bit. Now I am going to do Y raw with a vector. Specifically I am writing. Let us 4 down to 0, Y1. What it indicates that? It is a bus now. What bus it is? W1 of 0, W1 of 1, W1 of 2, W1 of 3 and W1 of 4. Now it becomes a bus. I understand. By default, if you are not declaring the vector, correct? If you are not declaring the vector, by default it will take 1. This try range net, which is by default this value is nothing but don't care. Then the default values of the Y net data type is nothing but a inference, means it is floating. You understand? What is the default value of this net Y data type or net data type is? Z means inference value. So next get the output value of their drive. If the next are not given and it gets the values on Z, it will get the value. The next get the output value if they are driving, continuously driving value. Right. So let us take this example. I'm giving A0, B0. What is this? What is this Y W1 is computing as? NAND operation, right? NAND in 0, 0 means 1. If I'm giving 1, 1, it is given as 1. W1 is given as 1. If I'm not having the A and B value, what is the default value of the W1 is nothing? This will be the inference. You can understand 35 except for what? Try reg net data type. So this try net reg data type by default value is nothing but X. You can understand what is mean by net data type? Set means sign potential value. So nets get the output value of their drive. If the nets have node V1 and it gets the values on Z, it will get the value, their value. The nets get the output value if they're driving, continuously driving value. Right. So let us take in this example. I'm giving A0, B0. What is this? This y W1 is computing as NAND operation, right? NAND means 0, 0 means 1. If I'm giving 1, 1, it is given as 1. W1 is given as 1. If I'm not driving the A and B value, what is the default value of the W1 is nothing but this will be the I for experience. You can understand the default value except for what? Try reg net data type. So this try net reg data type by default value is nothing but X. You can understand what is mean by net data type? So another type we have is nothing but a reg data type. Okay, before going to the reg data type, let us understand few examples of the Y data type. So now look at this example. What is this YA is? YA is a net data type. What is the default value of this is nothing but? It is Z. And whether it is a vector or a scalar, this net this is declared net as a what? Scalar. Right? So in this above circuit, now go back to this circuit. This is A is nothing but what now? It is a net data type. In this net data type, where net is what? Here YA is nothing but declaring as a net A for the above circuit and operation. Now if I'm writing Y become a C, what is this is nothing but now? Now if I'm writing WC is nothing but this is declaring two Y's, B and C for the above circuits. And the Y D is equal to 1 tick B0. What is this 1 tick B0 means? It is a size number specification. What number specification this will tell you? 1 tick means 1 bit. 1 tick B means what? Binary. 0 means what? Binary 0. We are assigning to what? D. Now what is my D data type is now? Now this net D is fixed to what? Log 0 at the declaration. So when you are declaring this as a net data type using Y keyword, when you are declaring declaring this as what? E0. If you are not declaring this 0 by default, what is the value of this is nothing but Z. I'm for instance. Did you understand this? So note that net is not a keyword, but represent a class of data types, such as net is having a class of data types. Those are Y data type. I said W and Y data type, WR Y data type, try and try R, and then try reg, etc. So these are the examples of what? Net data type. So most commonly we will be using, frequently we will be using the Y data type is nothing but what? Y among all these. So the Y declaration is used or is most frequently used. You can understand this? Okay. Now other data types we have is nothing but a register data type. Where register data type is a discrete driven data type. Why we call this a discrete driven data type? It stores is capable of retain the data. So we call this nothing but a reg data type. But this register is not same as what register you have studied in your DST like using flip-flops. Correct? Those registers commonly will be having a clock signals. For each clock pulses, data will be shifted, what shift you are doing, or rotation, right shift or left shift, or what configuration you are doing. So these registers are totally different from the register what you studied in the digital system design. These registers can just used to representing of storing of what? Elements. So this register represents to store elements. So this registers retain the value until another value is passed on to them. So this register will store the value. Okay, that's why we call this a discrete driven data. It will store the value until what? You are giving the new value to the register. It will retain the same value. Okay, so registers retains the value until another value is placed onto them. Do not confuse with term registers, what you studied in your digital system design, correct? So do not confuse the term registers in the Verilog with the hardware registers. Hardware registers are basically built using what? Flip-flops. Means those are edge triggering flip-flops in the real circuit. So this is totally different from what you have studied the registers in the digital system design. Those are designed using flip-flops with the clock mechanism. Okay, so these registers are just it is capable of stores until the new value gives to the register. Okay, the name we can use register, but the both more or less both are common usage, but this will be not having a clock. Those registers will be having a clock. So it is some sort of control mechanism. Based upon the clock, you're shifting the data to the right side or the left side or rotating. All these operations you're doing in the original SIP register operations. You understand? So in Verilog, the term registers merely means a variable that can hold the value. With respect to the Verilog perspective view, if you are talking about a register or a reg, what is the use of this reg is nothing but it is a variable which is used to store the value. Correct? If you are not declaring the vector to the reg by default, what is the size of that reg? If I am writing reg A, it's nothing but scalar. Reg 2 down to 0 of A. Vector with what? Width of 3. 2 down to 0 means what? 3. So unlike in net, register do not need a driver. It is not going to drive. Verilog register do not need a clock at the hardware register. What we are studying. Assigning the new value to the register. Correct? These values are changing. When you are assigning the new value to the register, it is not depending upon the what clock pulse you are giving. So those original registers are designed using flip-flops with the clocking mechanism. So these Verilog registers, the values of the registers can be changed anytime in the simulation by assigning the new value to the register. So register data types are commonly declared as a keyword called as one, reg data type. How next are declared as what keyword you can use? Byte data type. So how to declare the register data type? No? It is going to use the keyword called as one, reg data type. Correct. What is my default value of the reg data type is nothing but x means unknown. Where whites are continuous driven, reds are discrete driven. Whites are not capable of storing what? Data. Correct? Continuously driven. If you are driving the inputs, it is going to continuously computing the value. Where register is capable of storing the data, so we call this a discrete driven. Correct? So where wire, how to declare the wire is nothing but net data type is nothing but using wire driven. And reg data type can be declared using what? Reg driven. So you can declare wire with the scalar, wire with the vector, reg with the scalar, reg with the vector. So the default values of the wire is Z. Z means what? Floating state. Floating state means nothing but a open state. So the default value of the reg is nothing but unknown state. Means X. It may be 0 or 1. Unknown is nothing but 1. It may be 0 or 1. So these are the two data types. Okay. So along with this, like in C, we have other data types in C, like what? What are the data types is integer, float, then character, then string data type, then round data type, correct? Floating point, 16-bit representation, round data type, etc. In Verilog, basically it will support 5 or 6 data type. One is net data type, reg data type, integer data type, real data type, and then time data type, and real time data type. So these are the data types which will be supported in the Verilog. Did you understand? So just before going to this another data type of the Verilog, like integer, real, and the real time, or time data type, so we'll speak about what is a vector in the Verilog. So what is a vector in the Verilog? So usually vectors are used for net and the reg data type. So net or reg data type can be declared as a vector. So that indicates that it is a multiple bit width. Multiple bit width. If the bit width is not specified, the default value is nothing but one scalar. That means it is 1 bit. 1 bit net data type or 1 bit reg data type. If I am writing wire W1 means 1. By default 1 bit. Reg A means 1. 1 bit. Wire 2 down to 0 W1 indicates 1. This is a first one. So W1 of 0, W1 of 1 and W1 of 2. Similarly, reg 2 down to 0 A means 1. The reg with the size width is nothing but 1. 3. You understand? So what is the syntax to declaring the scalar and vector is? Suppose I am writing like this. Let me check the TB, module TB. I am declaring reg A. Reg A is nothing but 1. Vector array is scalar. Now let us assign A is equal to 2 tick B 0 0. A is 2 tick B 0 0. Let me print the A value. A is equal to, in binary I am going to print $ B, comma A. So what will be the output of this? I am assigning A to how many bits? 2 bits. But I am declaring this as 1. Scalar, 1 bit. What is the output I am going to get? Only 0, single 0. Correct? Single 0. Why I am getting single 0? Since my register is 1, scalar. Now if I am going to include in the vector, how to include the vector? Using square bracket before the variable. A is the variable. Now I am going to write 1 tick 0. 1 tick 0, so 1 colon 0. 1 colon 0 is nothing but, now this is nothing but 1. Vector now. What is this vector width of this A is 2. Now what is the output I am going to get for this? 0 0. Now this is used to store. Registers are in Verilog used to store what? Data. It will retain the same A value 0 0 until you pass 1. New value to this. Now I am giving what? 2 tick B 0 1. Now what is my A is 0 1. If I am making this is size is 3. Still it is 0 1. Why it is 0 1? Because my vector width is nothing but 2. Now still it is storing as 0 1. Correct? If I am making this as 2 down to 0. 0 0 1. Now it is storing as 0 0. Now simply if I give reg A, 3 tick 0 means it will store only 1. If you are not representing the vector here, by default, that is a 1 bit scalar. It is the same for wire data type also. If I am writing wire A, what is the default size is 1. What is default value of wire is? Now I am going to write reg A. Okay. What is the default value of reg A is? Unknown. I am not assigning any value to this. I want to see what is the default value of this. The default value of this is nothing but 1. X. Did you understand? Unknown. So the default value of the wire is 1. Send value. So this is what? The vectors. So if the bit width is not specified, the default value is a 1 bit. Now you can see wire A is nothing but 1. Example, you can see this example. What is wire A is? It is a scalar net variable. Default. What is this is nothing but wire 7 down to 0. It It is a 8-bit, I can call a bus. The variable I'm using as a bus. Now it is nothing but what? 8-bit bus. What about this y? 30 down to 0. Bus A, comma, bus B, comma, bus C. How many buses I have? 3 buses. Each bus will be having what vector is? Each bus will be having what? 32 bit. Now bus A will be 32 bit. Bus B also 32 bit. And bus C is also what? 32 bit. This is nothing but 3 buses of 32 bit width. You understand? Are you clear? What about this reg clock? This is scalar or vector? Scalar. This is scalar register by default 1 bit. What about this register 0 colon 40? This is nothing but 0 colon 40. What is this virtual underscore address is a variable. Now this is nothing but 1. It is a vector. Vector of what? The virtual address of how many bits it is? 0 to 40 means what? 41. 41 bit y. Bits y. Are you understanding this? So vectors can be declared as 2 ways. One is high or low or high. Means you can write 7 colon 0 or you can write what? 0 colon 7. What is 7 here is high value. 0 means what? Low value. If you have 0 colon 7, 0 is a low value, 7 is a high value. But in this vector, the left side, this left side number is a 1. Square bracket is always be 1. Most significant bit of the vector. Most significant bit of the vector. So you can tell me, for this how to write the vector, I am writing reg 7 down to 0 of A. How to write the vector to this? How it is declaring as a vector here? A of 7, A of 6, A of 5. Correct. What is the most significant bit is 7. Now how it is, how you can declare this as a vector is A of 7, correct? Next is what? A of 6. Next is what? A of 5. Next is A of 4. Next is A of 3. Next is A of 2. Next is A of 1. Next is A of 0. In this vector, the least one is what? A of 0. Most bit is what? A of 7. Suppose if I am writing like this, reg 0 colon 7. Okay. What is this? A of 0, correct? A of 0, A of 1, A of 2, A of 3, A of 4, A of 5. This is nothing but A of 6 and this is nothing but A of 7. So now in this case, which one is the least? A of 7. Which one is the most? A of 0. A of 0. You can declare this way or you can declare this way. Now how to find out the size of this one? What is the, how to find out the size of this one is? What is the formula to find out the size of this? Size of the vector. The size of the vector can be find what? Which one is the most significant bit is here? Some. Least significant bit is 0. So you should take absolute values of this. Absolute values of what? Absolute values of 7 plus what? Absolute values of means I can write how to find the size of this is MSB plus LSB plus 1 or minus 1? Plus 1, correct? I can write this is nothing but MSB plus, correct? Which one is MSB here? 7. LSB plus, correct? 1. Now what is MSB values? 7 plus 0 plus 1. The size is nothing but what? 8. What about this one is? What is size of this reach 0 down to 7? 0 plus 7 plus 1. What about this one? If I am writing range minus 5 colon minus 2. What is the size of this is then? What is the size of this is? Yes. What is the size of this is then? Is it correct way to represent the size here? So whatever the range I am specifying in the vector is correct here. Is it yes or no? This is nothing but what? This is 7. How this vector is declared in this case is how it is declared in the vector is 7, correct? Then 6, 5, 4, 3, 2, 1 and 0. Correct. What about this one is? Minus 5, minus 4, minus 3, minus 2. This is correct? MSB and LSB. What is size? How you can find the size of this is? I want to find what is size. From this you can tell size 1, 2, 3, 4. So using formula how to find out this? So size is equal to, correct? Size is equal to, now I should take absolute value. Absolute value of what? MSB plus absolute value of what? Is it absolute values of the LSB? So this is nothing but absolute values of MSB minus LSB are plus 1. What is MSB? Easy. 5. Correct? If I take absolute value 1, minus 5 is nothing but 1. 5. Did you understand? Or minus 5 minus of minus 2, what it becomes? Minus 3. What is the absolute value of minus 3 something? Plus 3. Plus 3 plus 1 means 1. 4. Did you understand? Are you clear? So this I can get what? Absolute values are. What is my MSB is? Minus 5. Minus of 1 it is. Minus 2 plus 1. Now what is the result I am going to get? Absolute values are minus 5 plus 2 plus 1. This is equal to 1. So absolute values are minus 3. So this is absolute value. AB is of minus 3 plus 1. This is nothing but what? 3 plus 1. 3 plus 1 is equal to what? 4. Did you understand? Now if I am going to write the vector like this, vector minus 7, or I can write minus 2 colon minus 7. Is it correct? So what is the size of this in nothing but minus 7 colon minus 2. This is nothing but what? Minus 2, correct? Minus 1. Is it correct way to give the range? No, right? Minus 2 colon minus 7 is not a perfect range, right? Minus 7 colon minus 2. That is a correct way to give. Because minus 7 is less than minus 2. Here minus 2, minus 7 is less than minus 2. Always this refers to what? This refers to what? MSB, most significant bit. This is correct if I am writing like this. This is correct way to representing the vector. No, right? So this is not a legal, right? Not a legal vector eclipse. Vector eclipse. You can understand? So if I give any size of the vector, if I give any vector, you know how to find out the size of the vector. Correct? So in this example, so vector can be declared at the highest value or lowest value to the highest value. But always this left hand side, left number will be square bracket is always will be representing most significant bit of the vector. So in example shown, the bit 0 is the most significant bit of the vector. In this case, vector 0 colon 4. What is the most significant bit is 0. Least significant bit is 1. Did you understand? For the vector declaration shown above, it is possible to address the bits or parts of the vector. Means range 7 down to 0 is nothing but 1. A of 7, A of 6, A of 4, 5, 4, 3, 2, 1 is clear. So you can see this example. In the above example, this is my bus. Why 7 down to 0 of bus? What is the bus size is nothing but 8 bit. Correct? 8 bit. If I am using bus of 7, bus of 7 means gives me what? It is going to give me bit 7 of the vector C. How do you understand? Okay, let us work on one example to this. Okay, you can try it tomorrow. I will be taking example on this. What I mean to say, this is my bus, 7 down to 0 bus. If I am using bus of 7, what it gives me? Bus A, sorry, this one, third example. It's talking about bus A. Bus A, bus B, bus C will be having what the vector size is. 30. There are 3 buses. All 3 buses will be what? 32 bit. If I am going to access bus of 7, what it gives me? At the value /7 of the vector bus B. What about this bus 2 down to 0 means? You can see this is bus 7 down to 0 bus. I am using bus 2 down to 0 means what? It is giving the least significant bit or most significant bits. Bus 7 down to 0, which one is MSB? 7. LSB is 0. If I am using bus 2 down to 0, from the LSB 3 bits, correct? What? Bus of 0, bus of 1, bus of 2. So 3 least significant bits of the vectors. For the same one, bus 7 down to 0, if I am using 0 to 0 colon 2, is it correct way to getting the values of 0 colon 2? Illegal, because the significant bit should be what? Always be on the left side of the range specification. And this is virtual address 0 colon 1. This is a legal one. It is declared as 0 colon 40. You can see 0 colon 40. Now I am taking what? Vector of 0 colon 1 means what it is going to access? MSB. Because 0 is MSB here. Now MSB of how many bits? 2 bits. 2 most significant bits of the vector virtual underscore address. Did you understand this? So there are some questions are there in InSkill regarding vector. How to declare the vector, how to find out the size of the vector, okay, how to assign the value to the vector, and how to print the part, means you are slicing out. This is nothing but I am slicing the vector. Slicing the vector. You can see how to slice the vector. You can work on that examples. Okay. So let me stop with this today. Tomorrow let us go with another data type. We call it as a integer data type, real data type, time data type, and real time data. So now we talked about the data types, net data type, range data type, and then how to initialize the net with the vectors, net with the scalar, range with the vector, range with the scale. So next class we'll begin with other data types, integer, real, and then real time and time data type. Okay. So now I request all of you to fill the attendance. Online student, you can use the link to fill the attendance. Any doubts are there, you can go ahead now.